So for figuring out area between two curves, let's start with the most basic example first. Let's try to find the area between two lines. So first of all, to find the area under the first blue line, we know we need to take an integral function. So do integral dx, right? So in this case, let's go from 0 to 4, for example. Okay, and then we know so the formula for that is then, of course, it's going to be the integral of our function, which is x plus 2 dx. And when we do that integral, that just becomes x squared over 2 plus 2x. And like we said, we're going to integrate that from 0 to 4. And we plug it in, we see 4 squared 16 divided by 2. So this part here becomes 8 plus 2 times 4 is also 8. And plug 0 and 0. So in the area, in the first scenario, is just 16. So in the area underneath this blue line from 0 to 4, from 0 to 4 is equal to 16. Okay, let's do the same for the green line. Since we're again doing the integral function, here the integral dx is just finding the area underneath this line here, and also let's just stop at 4 on this one as well. Okay, so doing the integral formula, so we got integral. In this case, our equation is x plus 1 dx. When you integrate that, this becomes x squared over 2 plus just x from 0 to 4. And then, of course, the first part is similar. That's also 8, x squared plus 2. And then instead of plus 8, it's going to be plus 4. So here we have 8 plus 4. So now we know the area underneath the green line from 0 to 4. This entire area here, that is equal to 12. So if we wanted to ask what is the area between those two lines, it's actually, we can visualize this by superimposing these two together. So I'm going to erase these integral functions here, or superimposing the line. So now I'm going to superimpose these two functions, and we see that the area between the two lines is just this area up here. And because we know that the blue area was 16 and the green area was 12, then we know that this area between the two, the red area, that's just the difference between those two, or is equal to 4. So the area between the blue function and the green function is just 4. So now let's look at a more common example of an area between two curves. So consider these two equations, y is equal to x squared and y equals to x. And we want to know what the area between these two curves are. Well, the first thing we should do is try to visualize what's going on. So let's see what these graphs look like. So here, I actually sketched both graphs out. All right, so I sketched them graphically so we can get a better idea what's going on. So we know earlier that when we do the area beneath a curve, we're just taking the integral of that curve. So to get the integral of the first one, it was just the integral of just x squared dx. And the integral of the second one is the integral of just x dx. But the question is, to find the area between these two curves, we first figure out where they actually intersect. So when we superimpose these two graphs onto each other, we see that they intersect each other at this position right here. And that value is an x value of 1 and a y value of 1. But when we're dealing with integral, we just need to know the x boundary, so it goes from 0 to 1. Therefore, now we can take these two integrals separately and figure out what the integrals are. So take an integral on the blue parabola, we get integrating that, we get x to the third power over 3 from 0 to 1. And integrating this equation over here, integrating the green line, we get x squared over 2. And we're going from, again, 0 to 1. And integrating the first area, we see that this area, plugging 1 in, we get an area of 1/3. And integrating the second equation, putting 1 in, we get an area of 1/2. Now, looking at the image, we see that the green equation, the green line, is actually on top of the blue line. Therefore, the area of the green equation comes first, so it'll be 1/2, and we subtract to that, just like the previous graph, the area of the lower equation. In this case, it's 1/3. Subtracting that, we see that we get, doing common denominator, we get 1/6. So that is the area in between these two curves. So 1/6 is this area right here, in between the two of them.